Hey everybody, this is Larry. This is me going over the recent Q4 of the Leetcode daily contest. Hit the like button, hit the subscribe button, join me in Discord, and let me know what you think. Today's problem, or the contest problem, was minimum 1-bit operation to make integer 0. So this is a really hard problem for me. I think some of it is that I was just lazy, to be honest. That I didn't really think through all the just all the cases. There are a lot of cases, and yeah, there's some stuff about grade code which you can Google on. I'll put a link here. Google grade code. So you can definitely. So it is apparently is very Googleable, and that's why a lot of people was able to solve it. But so the thing that you can do is just by paying attention to really thinking about what these things mean, right? And the observation about these two rows is the tricky part. And the way that you can solve this is just by recursion on the number of bits. And because n can only be up to 10 to the 9, there will be at most 32 bits, so you don't have to worry about that much. I actually was even lazy if you want to consider that, and actually just use strings. And I didn't even use index of the strings, though I probably could have rewritten this in that way. But basically, given a string, a binary string, which we convert the number n to, we first kick off the problem by asking ourselves the question: how can we change the entire string to 0, right? And then there's just a lot of cases, which is kind of tricky. But we'll go for it one by one, and then maybe it'll build your intuition. I would say I did not solve this during the contest. You could watch me solve it live afterwards because I was too stuck in. I was trying to solve it in many different ways in my head because I was close. Like I felt like I was close in the different ways, but I didn't just commit to one way. If I had just committed to it this way, then I would have been able to get it. There's a couple of ways to solve this, but this is the one that I prefer to like because this. Some of the other stuff requires Googling or knowing facts that are kind of weird to know. For me, the way that I solved it now, I am able to figure out from first principles, right? So, and actually this could be memorized, but the first thing to note is that there is a little bit of a pattern, which is how this gets called, and yeah, and you could actually use dynamic programming or memorization to figure this out as well. But the idea here is that if you have a number of 1 and then a set number of zeros around it, it actually ends up, and this is a binary number, not 10,000. This actually ends up taking 2 to the, in this case, 5 or 4. Is it 5 or 4? Let me take my notes. 2 is 4, so yeah. Right, so yeah, so this is that 5? 2 to 5 minus 1 calculations to convert this to 0, right? And you could kind of play around with it. I mean, I know this is after the contest, but if you just run it, yeah, 32 will take 2 to the 5th, or sorry, I guess this is 2 to 6 minus 1. Maybe I'm a little bit off by 1, but yeah. Right, so if you figure out the pattern here, then yeah, then you should be able to do this recursively, right? Sorry, it is a tricky problem for me to explain because it is a tricky problem for me in general. But yeah, but the idea is that, okay, how do we change the 0, right? Well, we go for all the possible cases, and this is with this in mind, because, okay, let's say you have 1, it takes 1 move to get this to 0. If you have 2, I'm just going for powers of 2, so 2 is 10 actually. 2 will take 3 moves, or 2 to the 2 minus 1. This is 2 to the 1 minus 1, and so forth. So maybe actually I did have an off by 1 here. Oops, can't do math right. And this is something that you can play around with to figure out why this is the case. And you can actually solve that and figure out by dynamic programming. Because this is just getting 4 of these and then converting to 1 zeros, and then multiplying by 2, right? So anyway, okay, so now let's say you have this, and this is the cost, which is why it shows up here. Let's figuring how to do this recursively by changing the 0. Okay, so how do you change a binary string to 0? Well, if it's linked with 0, then you're done, I guess. Also, I think, yeah. If the length is 1, and then we're very easy, right? If the length is 1, then if the number is already 1, then you just have, then it costs 1 operation to turn to 0, because we could always change the rightmost bit. So this explains this base case. And then the case is, okay, if it's already 0, so this operation actually, oops, change x to 0 or zeros, right? So if the prefix is 0, then yeah, we're just going to look at the next character, right? Or yeah, because it's already 0. However, if it is 1, that means that well, if the first string is 0, then it's good. Otherwise, then that means that the first character is 1, right? And then you have like some characters after that, right? And then the question is, and this took me a while even up solving, and the question is, okay, there are 2 cases obviously. One is 1 1 8, you know, some other characters afterwards. I wanted to use x, but I didn't, you know, because we use x as a character here. What does this mean, right? Well, this means that here, to get rid of the first digit, right? So this is what we're saying. If we have a 1 in the first digit, we want to get rid of the first digit. How do we get rid of the first digit? We can only get rid of the first digit if there are 2 cases. One is if the second character is 1, then we have to convert all these to zeros, right? We have to convert these to zeros, and that's what this recurrence does. It changes 0 to 0 or the suffix, and then now after this cost, that means that we have this string, and after we have this string, we have 2 operations, or well, we have 1 operation that to take it here. So it's this plus 1 plus convert. Now you have the new a power of 2 number, and that's where you get this 2 to the x minus 1, and from that 2 to the x minus 1 you add 1, so that's why it's this. So yeah, and then so that's the case if the second character is a 1, and this is the case of if the second character is a 0, right? The second character is 0, then you have something like this, and it could be a bunch of stuff that may or may not be 0. So we want to change, so what we want from here is that we want to change this to a 1 somehow, and then that's it. And then you have all these A's. And now we have a second recursive function that goes change to 1, right? So what does change to 1 look like? Change to 1 is change first character of x to a 1, and then the rest to 0, right? So that we get this power of 2 number, right? Because here, for example, we actually want to, you know, to get this number from here, and from here to get to here, well, the first character has to be a 1, and then the second character has to be this suffix, which is what we do to change to 1 using that suffix, right? And then again, this is just very base case, a lot of cases in enumeration, which is that if x is 0, then we turn 0. If we only have 1 character length, then we either change it or we don't. That's the 0 in the 1 case. If the first character is already a 1, then we just have to make sure that the remaining of the characters return to 0, right? Because that's how we match this, you know, we have 1A, you know, 1 A, B, C, D, E, F, G, or whatever to 1, 0, 0, right? That's what we want to do with this function. And in this function, we want to just convert it from A, B, C, D, E, F, G to all zeros, right? And how do we get from here to here? well, actually, this could be it doesn't have to be start with an one. Sorry. Well, here if the first character is 1, then we know that we just need to get the rest to zeros, and then otherwise we know that the first character is a 0. So then, how do we get the first character to be a 1? Right. Well, the first character can be a 1 if you change the second character to be a 1, and then the rest is 0, right? Basically what you're saying is, okay, so now the first character is a 0 and you have some A, B, C, D, E, F, G. So then if the second, so we have a O1 prefix. Well, here all we have to do is convert all this to 0. So we have to convert this to 0, 0. Make one move to make this, this, because that's the second operation, and then now we can convert this to 0, right? So now it takes this 2 to the some k minus 1 operations to get there, and this takes 1 operation together. You have this 2 to the k, where k is the length. So that's kind of basically the idea here, and the same thing for 1. This is very exhaustive. I'm going for every case, but basically you have 0, 0, A, B, C, D, E, F, G, H. So now you have to change it to 0, 1, A, B, C, D, E, F, G, and then after that, you have to convert this to this, which is what this function is supposed to do, and then again the same thing is here, right? Now that you have here, so basically the difference in suffixes explains that. So that's basically the recursion. That's how you do it. That's how I would do it. And you could actually memorize this if you like, but it seems to run fast enough without it. Just submit just to show you. And yeah, so basically that's pretty much how I would solve this problem, and I really should have solved this during the contest, to be honest. And if you add memorization, you can prove that you look at each index at most once for each of the 2 functions, because we never change the suffix, right? So from that, it's linear time, linear space in terms of the number of bits, which is 32 up to, right? So it was going to run pretty fast. Yeah, I really should have solved this during the contest, even if I didn't know about Leetcode. I just didn't really trust myself, and maybe I was a little bit tired from Q3. I think maybe if I had used a Q3, maybe I could have grind this out. I just didn't grind it out, and that's something that I hope you learn from my mistake, because this is actually pretty straightforward once you have the right. Once you commit to recursion. This is pretty straightforward, to be honest, right? Because it's just going for the cases. It's just that when I was doing it during the contest, I had trouble going through all the cases. I was doing this thing during a contest where I was looking for a shortcut of like, maybe there's an easier way to do the formula by using for loops or something. And if you watch me do it live, you might have seen parts of that. But otherwise, yeah, I really should have done it this way. Anyway, that's all I have for this problem. Let me know what you think and watch me solve it live next. Thank you. Okay. That was a rough one. Rough. A lot of people got in Q4. But I got in Q3, so if I just finish okay, then I could still be good. It's been way too long on this one though. Okay, let's kind of cheat a little bit and see how long people took. Only 21 people got Q4, so it wasn't even that much, but people still took like 20 minutes, so it's not an easy problem for sure. Well, except for for some people. Okay. Yeah, okay, focus. I think this is where the pen and paper have. I still have 50 minutes. I have enough time to solve this. I always want to do that. That's true. So every power of 2 has some weird thing where it takes 2 times whatever, but do we do agree? In this case, wait, what does that do? Well, six for 4. Which makes sense. Obviously too big of a number to do DP. Well, at least DP in that way. So DP under 32 bits. us how this. A lot of people do though. Let's make it. That's fine, not right, but 6 is 4, is that right? That's right. 7, I don't know. Why not 5 though? So 6. What's 6? I'm missing a step. Five goes to 7 probably. Yeah, I think I messed up, but 5 goes to, no, 7 should go to 7. So I guess my thing just doesn't make sense. I'm trying to do something dumb and I can't even get it to work. Four goes to 5. 5 goes to 7. 7 goes to 6. What, 3? Yeah, I think my formula was wrong, but I might not get it. Wow, a lot of people getting it. That's 12. I think I know the pattern, but it reminds me of a code force problem I saw, but that was a really hard one. Well, for me. About each quadrant and what did it go through? See if I could. Funny thing is, every number depends on itself. Like it goes for every path once, so it's a really weird thing. Reminds me of a weird Hilbert curve type thing. Do it bit by bit. I mean, you can do it bit by bit, but I have to figure out the recurrence. This second bit is sealed. So the biggest bit is 2 plus 3. That's 6. 6, 4, yeah. That's what I want to do. If it's 0, we do a reverse. That's not quite what I want. Okay. So actually we should. 22. Close enough, I guess. I didn't think this was right, but it's something related to this, but I'm not quite getting it right. I don't think. I'm missing one thing, which is the order. I think I'm missing the order as well. So this is so up to 8. They will have a 4. Then the 2-bit. So this is a 1. Should converge. Yeah. What is the intended answer? 2, 4, 14, 393. So 1. Take the smaller half. So now this is 1. Maybe I'm just not going to get it. It's too mathematical for me. It's not quite right. If it's a 1. Nope. I'm just trying random crap now, to be honest. Though it seems to fit actually the first 3 numbers, but not the last one, unfortunately. I mean, this fits what I have for the first 8 numbers, but clearly it doesn't really work for 333. So, yeah, I mean, I'm happy that I got a pseudo-fitting thing for part of it, but there must be something more recurring. Something like 1 bit at a time or something. 8 is what? 13. What's 13? 8, 5. Yeah, so this is 8 because it goes to 7. Oh, it goes to 4. This isn't right. I think this is just not right, to be honest. But it's right for the first. Maybe something got lucky. Because 13 is 8 plus 4 plus 1, and that, according to this, it goes to 4, which is just wrong. Right? Like, there's just no way. So what does this go to? Let's go to 12. And it goes to 4. Okay, I mean, it's not off by much, but my 8, 12 and 13 is mixed up a little bit. Why is that? What is 12? What is magical about 12? What is magical about 2, 6, 12? This part seems okay. Four goes to 12 makes sense. I'm just trying to express it in formula, and equivalently 8 goes to 24 is probably the next one, but I don't think I do that right. So what's special about 24? Well, it writes Maybe it's just TP and I'm being dumb, to be honest. Let's see, what is this? It's probably just TP, and I've just spent a lot of time not thinking about it. So basically the cost of doing this is equal to the cost of flipping all the x's, is that right? If it's 0, then it's just the cost of I think I have an idea, but I don't know. This apparently I was just really slow today on this particular one. Not a good showing for the defending champion, but okay, let's just do get 0, maybe. House. This is a 1. Flip to 1 of index plus 1. And then flip this one. Flip to 0 assumes that this one has a 0, so let's do that. Oh, this one is a 1. This recursive thing is not seeing the states well. I might upsolve this after the contest, so but let's see. So there are two problems. One is just given an initial thing. feel like I could do something with this. Something like that. I was doing something similar, but still not right. I'm off by something. I feel like I have a good intuition, but I'm just missing something weird. Oh well. Some days you kick butt and some days you don't. Yeah, oh well. I think I got to. It's something like this, but I'm trying to figure out how to do it right. But I'm gonna upsolve this. Oops. Poop. like I did this, but I'm missing something a little bit weird. Is that not a, oops, copy and paste? That was close, but I don't think this is right. But, oh, whoops, this is times 2. Just one. That was kind of a rough contest, mostly on the Q4. Let me know what you think about me solving this problem, and I will see ya next contest. Bye bye.